Hello, everyone. Welcome to today's developer coaching webinar. My name is Tara Van Cleve, and I'm part of the Developer Relations organization here at Oracle. And today we're excited to show you how to deploy and manage GPU accelerated workloads with remote direct memory access connectivity on Oracle Cloud Infrastructure Kubernetes engine. I'd also like to note that we are recording the webinar, and you'll receive the replay via the same email that you registered with after the event concludes. If you have any questions, we've enabled the Q&A section of the Zoom, and we will answer throughout the hour, as well as leave some time at the end for any remaining open questions. Today's webinar will be presented by Sasanka Ebising, Principal Cloud Architect. So without further ado, Sasanka, over to you to take it away.
Yeah, thank you, Tara. All right. Yeah, thank you for joining today's session. So today I'm going to cover running RDMA GPU workloads and the Oracle Kubernetes engine. So my name is Sasanka Basing. I'm a cloud architect for the Code Innovate team. Here with me, I have Varun Yadav. He's also from our team. So he's from the going to help with the Q&A and for the Code Innovate pitch. So the today's agenda, so what I'm trying to do, I'm going to go with the architecture for the RDMA GPU workloads on OKE. And then I'm going to move to the stack deployment overview from the resource manager. And I have ready to demo. So what I'm going to do for the how we are going to do the GPU workloads into the OKE. And after that, Varun is going to go with the code innovate. So with that said, going for the architecture. So this is how it looked like for how we are going with the high performance computer cluster stack for OKE. So normally we are going with the couple of important points like important nodes. So the first one is the Bastion host. So that's the one we are trying to connect from the outside world. And from that is like we are going with the public IP. And with that, I'm going to SSH into the operator instance. And that's the one we have everything it's installed. So for example, the kubectl and all the commands, softwares I install over there. And from that, I directly jump into the Oracle Kubernetes. From that, we have system worker node and the worker node for the CPU. For the system worker node, we use for the as a op node, and for the worker nodes, we use as a CPU node. So typical like when you're deploying the Kubernetes. So we normally deploy those the worker nodes like for the CPU. For adding part, we are going to add another worker for like a two worker for the GPU, for the GPU computer nodes, and also we added another part for the GPU for the RDMA. So with that said, we have like include the per system volume. So with this stack, it's automatically create the we can create many things like FFS storage for the mountain, and also if you want we can create the object storage, and also we can go with the many storage devices, and from that we will going to expose the Kubernetes API as a public endpoint or a public private endpoint. So when you deploy the Kubernetes, we have like a two different cluster types. So one is the enhanced cluster mode, so which most of the customers they use as a production and stage for a test or a development environment. So and the other one is the basic cluster, so which most of the time we use as a sandbox environment. So mostly the people go with the if you have like a core functionality that is provided by Kubernetes and Kubernetes engine, that's what mostly going with the basic cluster. But for the production ready or as testing environment, we will highly recommend to go with the enhanced mode, which is include all the features and supported not supported by the basic cluster. So for here, we have like a many nodes type. So the first one we call the manage node, and the second one we call for the virtual nodes. So so the what we are trying to do, like these three type, and the managed nodes and the virtual nodes, when you're doing with the normal Kubernetes deployment, you can see like that. But for this one, we added the self-managed node. That's another thing we need to go with that. So the virtual nodes we normally typically fully managed by the Oracle. So the managed node is somewhat we going with the computer instances, and from that you have like a partly managed by you, and it's either we can go with the bare metal or a virtual machine. So with the self-managed node, so the as the name implies, so the self-managed nodes are fully controlled by either you, so which the provisioning, scaling, and configuration. So those kind of maintenance tasks for the like a patching wise, everything is fully controlled by you. So this is the key feature, like you'll get more controllability. You can do the custom configurations and manual upgrades. So it's kind of a have many control, like a customer has like a many like a full controllability. So that's why we are going to self-manage nodes. So with that said, we already have those add-ons. So basically, it's coming with the Kubernetes cluster. So either Istio, Kubernetes Proxy, Cert Manager, or Autoscaler. These kind of things are come up with Kubernetes. So so the next topic, I'm going to go with the AI building block for these enterprises. So mainly when you're going with the GPU workloads, I think most of them planning to put some kind of platform frameworks or models you are going to deploy it into the GPU. So we do have those kind of availability for the platform like LangChain, PyTorch, NVIDIA. Those all are supported by from the GPU with the CUDA drivers. And for the developer services, we from this stack we can go either Grafana, Prometheus, and Kubeflow. We already included this in the stack. From the from the AI infrastructure perspective for the NVIDIA, from not included in this stack, but in the Oracle by itself, we have like a GPU supercluster. These are like what we are discussing: Kubernetes Metal, bare metal, and the VMs. And also for a storage wise, we have the file storage, object storage, local NVMe, and the block storage. So the AI services, we have our own generative AI models, like either we can go with the Gen AI or Agent AI, vision, speech, document understanding, and can go a lot with the digital assistant and data science. So with that said, like we already have the database services like vector search, select AI, or vector search, or not, or either we can use LLM on the database. And also we come up with the data platform side. We already have, you already know about the databases like Exadata, Autonomous. So the recently we had the multi-cloud, which is the database at Azure, database at AWS, and database of Google Cloud. So these things are provided from the AI building blocks for this for the enterprises. So the next, we are going with the what kind of a common use cases we can see it from the GPU level. So I know like there are many you can go with for mainly you can go with the graphic rendering, like a scientific computations. So mostly GPU facilitate fast computing complex simulations, either for subjects like physics, chemistry, or biology. And you need to be like really good in artificial intelligence and machine learning. So in the training models with the large data sets, GPU is significantly enhance the workloads, like speed and efficiency. And also with the video and the streaming, so which also with the generative like Gen AI and high performance computing, So we'll get more high quality and streaming power. And for the super cluster with the Blackwell, and we got most demanding in the LLM and generative AI workloads. So, so with that said, I will move to my demo. So what I'm trying to do, like so this is the quick start, what we can find from the Oracle. So it's recently like these are like a contributors we in here. They're like a highly efficient, like you can see like a last week also we got the update, and really thankful for them to implement this one. For the right now, the supported operating systems are Ubuntu 22.01 and Oracle Linux. So those are the two operating system right now for the supporting. And if you are not an administrator, we need to create a policy for the cluster creation and the deployment. And for the you need to have the dynamic policy for the self-managed nodes. So everything is included here. If you can click, you can directly go into the how you can implement the dynamic policies for the if you're not an administrator. Since I'm an administrator, so I'm not going with the policy creation. So it will create by itself in the when you click here, it will directly going into the resource manager. So what I have right now, I have it here in the resource manager over stacks. So this is the place it's going to open. So once you click here, it will directly go to the, like if I could edit. So this is go to the, so I already provisioned it because this took me like 35 40 minutes 20 depending on the things I'm going to provision. So what I'm trying to explain here, so here we need to get so these two operating system. So what I do, like I download this image, so this one, and then I let me go over there, and I put this image into the custom image, and I upload here. You can import it, and you can directly either you can put it into the object storage, which you can directly give the link, and then you can do the import image. So that's what I do for here. And then if I go back to the stack, so first thing, either you can run this as a resource manager, or either if not, if you can go over here, you can directly click the folder, you can download it, and then you can run from your command line Terraform script as a normal Terraform apply plan. So those commands you can directly run from that. So for the demonstration purposes, I imported here for the resource manager, the way we normally run our Terraform scripts. And from that, so you can see like because of since I'm an administrator, I was able to create all the dynamic policies for the auto scale and self-managed nodes. And it's assume like everything is going to be created for the as an administration for the network side. So first we are going to create the virtual cloud network for this one, and we giving the cider block. So for like if you have like a either you can go with the comma separate list for the, and also because since I'm going to expose my Kubernetes as a public endpoint, I created a public subnet, and also I'm planning to create load balancers, so that's why I go with the public subnet. So then if you're going with the bastion and the operator, the compute instance I'm going to create. So I'm going to create the Bastion host with the SSH access to the VCN. And so normally I'm going with the one I did is I'm going to connect from the public internet. So that's why I need to SH from the bastions since I have need to have a public IP. So right now I allow everything from the bastion allow for the cider. This is an optional step. Either you can ignore it. So then I create an operator instance, which is going to connect from Bastion host to the operator instance, which is everything you can access the Kubernetes endpoints from there. So either these things you can change the shape depend on your requirement. And for the OKE cluster, so I have like a cluster. I'm going to create like a my compartment level, and I'm giving the name, which is either for the purposes of the naming convention, and we'll go with the Kubernetes version. Either you can select the latest version, so I'll go with the default 1.33. And for the I'll normally like here for the pod communication, I use the VCN pod networking. So here it is recommend to go with the pod networking or a flannel. So I will go with that. So then for the endpoint, so I create the endpoint as a public subnet for either you can uncheck this one and you will get the private endpoint. So here I'll get the public endpoint. And from there, I added everything I'm going to allow just for a demonstration purposes. And from that, I create a load balancer for the preferred load balancer in case I'm going to deploy any AI workload. I want to expose it as a load balancer. So this is the system, the worker node. So I just with bare minimal like a worker node number one and with the availability domain. And here I use the standard flex and the minimum CPUs with the OCPUs memory and with the boot volume with the default one. And for this one, I use the canonical Ubuntu. So which is the one here for the OKE purposes. And for the CPU, I use the same image with the same configuration for the worker node. But here as well, I just put the one worker node. And for the here there is an important part with the GPUs. So either you can go with there are two different ways. Like here we can include the GPU pool with a OKE manage pool with the resources, and then you can get the image which I uploaded in the custom image, and then you can directly import it from here. So if you can see like Ubuntu is already displayed right now. So if you need to have a RDMA enabled, so what you can do, you can here you can create the worker nodes. So by default, it's for number 4. And the shapes you can select from here, or you can have a like already have the custom image you want to upload. So with the NVIDIA CUDA drivers, so it's already you can do it from the custom image section, the one I showed, and we can get it from here. So for this demo, I'm not going to do it because so I don't have much availability here. So for this bare metal GPU instance, so the one I'm looking at, so with the VM GPU 810, so that's what I provision. So this took me like 25 minutes to get it done, everything. For here, for the Bastion host access, I need to upload the public key. And from that, I use my public key, upload it, or I can paste it here. For the storage devices, you can either you can give the NVMe drivers or OCI block volume. So for here, I used file system storage, which is going to automatically create from that. For the monitoring purposes, I click monitoring stack as well. And for the stack configuration, I go with the default on its topic deletion for the stack destroy. So with that said, so when you have that configuration is available, either you can click plan and see what are the things you are going to deploy. And once you are happy with that, you can directly go with the apply command. So once you save all these configurations, so what I did, so once you have everything is applied, so you can see everything is going to, what other things is going to completed, and then you can see all these important um, things you can get it. So you can see like SSH command. So here you can see you can directly get the SSH command into that uh, operate instance. So all these things you can find it from here. Excuse me. So the application information. So then you can get it for the monitoring URL. So you can get it from there. So what I'm trying to do, like I'll get this the Grafana monitoring and then copy it, and I'm going to paste it here. And from that, I'm going to open it. So since I'm already uh, open, because I already have that before this presentation. So what you need to do, you need to get the admin, and you can copy and paste the password. So what I did is here, it's already, I log in as an admin. So then you'll get it in the Grafana. So either you can get Grafana from from the Grafana, you can directly import from here. So see, you can get it, which I get it like I directly get from the this dashboard. You can if you are not familiar with the Grafana, you can directly download it here, and from that you can, from here, either you can import the dashboard. So that's what I end up here. So here you can get everything is, you can filter by depend on your scenarios. Like I have like a namespaces and pods. So if I have like only the Nginx, I can filter by Nginx namespaces. And so this is something for the monitor perspective. So which you can go with that. For so the other piece I want to show is, so if I go back to the shell, so I'm trying to log into the operator instance, so which we can find or here, or so the SSH command. So what I'm trying to do, I'm going to, this is my private and the keys. So I'm going to get the, from the Bastion host, I'm going to access into the operator instance. From that, either you can directly, there are so many things, like you can directly access to your nodes, but K9s is also installed. So here we can get more information about the cluster, because it's pre-installed. So either you can go with you can see the pods. What are the pods you can see? So you can directly go with that and you can do all these things. So what here, if you want, you can move to the namespaces and all these things are you can get it from that. So here, so if you want to go with all these things, the things, pod services or users. So basically, this can be used as a dashboard, which is already installed in the operating instance. So with that said, I have like a one simple, yeah. So I create like a services for the NIM microservices. So what I'm trying to do, like I'll get some kind of the pods what I have. Let's see if I get here. Yeah. So I deploy the NIM microservices for so what we can run. So the meta llama instructor. So with that said, we can get the as a chat model. So what is Oracle database, and it will automatically give this one as a, so here I use as the load balancer. I expose it as a load balancer. So this is my IP address, which I put it here. So then once you ready, you can click run and you'll get the information depend on the content. So how we can do this one? So I'm going to tear down and see how we can get it done. So normally in the in NVIDIA, we have many tutorials if you can go with that. So here either you can go the model, you can download. So here we can get it. So there are two things you can get, like get this NGC secret and the API key, which we can get it from we can create it from, I already have it here for the setup keys. So if you can create just a personal key. So I just create one, and from that you can insert it as a, so if you can get secrets in, I from here we can get it. So I already include this Kubernetes secret for the NG secret and API secret. So from that, so here that's how you can create it. So what I'm trying to do, like I'm going to export. First of all, I'm going to tear down what I already have. So let's go back here because I'm going to uninstall my Helm chart. And from that, I'm going to get this value, the personal key token, and I'm going to export here for, and then what I'm trying to do, I'm going to get the Helm chart from that key to fetch it. And then from that, I'm trying to install from, see, you can see like everything is included here. Like here you can see what is the llama model. We are going to the location. So since I already have the GC secret, I get it from the NVIDIA side. So here I have it in my, like, if you go back one level up, you can see like this is the YAML file, but oh, it already has. So this is basically I was just trying to get the same thing from in the here for the there, but the only difference is I'm going to make it as a load balancer, like a service load balancer. So that's why you can expose it into the public. So, so with that, I'm going to run the Helm chart from the one I have it. So it's deployed. When it is deployed, you can see what are the pods it's going to deployed. So you can see like this is the one I deployed. The container is creating, and so it will take time. Like little time, you can go with watch, and once it's ready, so it'll take it as a like a creating a load balancer, which I put it here. So and then you can get the same command. What I will wait one more minute and see if it is running. Yeah, it's running now. So what we can get the same command with we get it for the get the services. So then you'll get the different IP address. So we need to copy and paste and put it here. And then you will see the same input what I ran previously. So this is the way you can go with how we can deploy the the models, the one I had for the NVIDIA for the LLMs. So there are many more examples. Either you can go with, there is another one I was just interested for the, so the image OCR. So this is also, you can directly go with, and there are so many tutorials you can, how we can set up. And same way, the way I did for this one, you can create the this one for the OCR, paddle OCR. And from that, you can directly deploy from the Helm chart. And then you can get expose it, and then you can write your own. This is something you can get it from the Python code is by itself, and you can do the work from here and get the from the logs you can get these values. So this is the one you can do it from here. And also there's a one more possibility, like if you are done with this one, we can directly import if you have the developer services. If you have like any project like a PyCharm or anything like a PyTorch or any kind of a GPU model, you need to do like a build and do the like a kind of a CI/CD process. We can directly go into the DevOps in the Oracle projects. We can build the steps, and then from that, we can, let me see if I have the correct one. Yeah, I'll change it here for the Ashland. So we have the pretty good the DevOps projects. We can directly go with that, and we can directly import the Kubernetes over here. So this is something what I did, like we can directly get the, either you can create manually or you can get it from the Terraform scripts to the build process. And from that, you can do the build and create the artifacts and directly deploy to the OKE. So, so here what I did, like basically what you need to do, like in the environment section. So here we have the environment. So from that, you can directly select your Kubernetes from here. From for what I had, it's in the Phoenix. So here I have this one, the one I created from there. So I can create, I can click here and then it will go and do the CI/CD for the one I already had, the blue-green deployment for the OKE. So which ones you run? So we can see we have the manual run as well. If not, you can directly go with the GitHub Actions and you can directly go with that. So here we can see how the build and how we can deploy to the OKE. And also we have like this is called the CI part. And if you go back to we do have the deployment as well for the continuous delivery. So the CD part. So either we can deploy to the OKE and you can get the approval and you can go with the shift. Either we need to go with the GPU route or you can go with the CPU route. So these things it's possible with the when you develop everything into the from that from the stack. So that's the pretty much it for the demonstration. So here, if you have like a so so since the GPU and everything is run, what you can do if you are thinking about, okay, let's go back to the next. Okay, now I was thinking, okay, I'm done with the GPU. So what I can do is like, okay, I don't want this one anymore. So then I can go back and next. So then this is the only thing that my GPU is not available. So then I'm going to click run. So then it will won't take like 20, 25 minutes, 30 time. It will take only that part and then destroy it. So this is the good thing in the this stack. So it's everything is going to be very efficient. And also for the storage wise, so I mean, I think you guys remember like when you're doing the edit, I click the file storage. So I have that one is clicked. So that then I got when you go to the storage and I can see in the file system, it's created my file system and also the mount target. So once you have this mount target is ready, so you can go have it into the PVC. You can directly sorry, into PVC. You can here we have like FSS. I have the here we can get the FSS PV. So you can directly the volume, you can, so the one I showed, you can directly the oscillator, you'll get this one and copy and paste into the here and you can create it from the, so for here I have like a mount demo one. So in the file system, you can get then copy the OSIT from there and you can create the persistent volume. From that, you can go and create the persistent volume claim. From that, you can either use it as a file exchange or any other deployment. So you can use it for that. Also, you can have either you can create from the Helm chart as well. So if you don't want to stick into this step, so that's the pretty much it for the stack perspective. Yep. Yeah, Varun, floor is
Sure. Thanks, Ashanga, for the demonstration. So I'll just quickly go through the pitch for the Code Innovate. So Virtual Code Innovate is 5 half-day event to jumpstart your journey to the Oracle Cloud. We pair one Oracle engineer like me or Sashanka with 3 to 4 customer developer to work with the use case that you bring. And by the end of the event, we aim to achieve a working prototype, right? And it is a good opportunity to showcase the solution that we build during the Code Innovate to your leadership. And it's a free service. We don't charge anything for the event. We only ask for the time commitment, right? And whatever we build, it's built in the customer tenancies. So it's built in your environment. We are just guiding you through the process, like how to build the use case. So whatever we do during the week of the Code Innovate is your property, right? So we don't ask for any access to it. So as I said, like we ask for you to bring the use case. We don't force you to work on certain use cases. So whatever use case that you have, we'll brainstorm. We'll see what is feasible for the Code Innovate, what can be achievable during the 20-hour sprint, right? And since we are pairing Oracle Engineer, right? So the whole journey is like a rapid knowledge share, right? So if you're learning something on your own, like what Shashanka has shown in this demonstration, right? Like spinning up the Terraform, Resource Manager, setting up the Kubernetes, all those things, right? Like if you're learning on your own, it would take probably like a month or a long duration to set up like everything, right? And since we are here to guide you, it's a rapid knowledge share, right? And it's a good chance for doing a POC or like build a prototype, right? So our aim is not to achieve a production ready solution by end of the week, since we can't do everything in 20 hours, but our goal is to help you build a first pass prototype so that you can take it with you after that 20-hour sprint, and then you can work on your own, or like you can take it to the next step, right? So what does the timeline looks like for the Code Innovate, right? So once, let's say we figure out the use case, or you are interested in doing the Code Innovate, we confirm the dates for the event, and then working towards the back, we set up the demonstration if needed, right? Like if you want to dive deep into the Kubernetes services, dive deep into the Terraform, just giving you example based on today's demonstration, but it can be any services in Oracle Cloud or in the past services as well. And then we do something called structured learning, which is a demo and tenancy configuration, so that we make sure that everyone who is participating during the event have access to the environment in the Oracle Cloud, right? And then finally we do the virtual Code Innovate, right? And since this are like half day event, we are flexible pretty much between 8 to 5 p.m. Eastern, so we can do either like first half of the day we can start from like 8 a.m. We can do like 8 to 12 before lunch, or do 12 to 4 or 1 to 5, right? So we are pretty much flexible in terms of what timing of the day we want to do the event. And the only thing that we ask from you is, right, like we ask you to bring the use case and time commitment, right? So we do this in 5 consecutive days. So we start on Monday and finish on Friday, and that's pretty much it, right? And we ask for like 4 or more developers, and it can be like depending on your team how many people you want to bring in, right? It can be like 10 developers as well. So just to think about, like since someone is going to drive the session, um, only one person can share the screen at a time. So that's why we ask for like 4 or 5 people per team. If you have multiple use cases, we can work in parallel as well. So it doesn't need to be just one use case. Yeah, you can bring as many use cases as possible, right? And we just ask for like 3 week of lead time so that we can prepare internally in terms of aligning the resources, making sure that everything is in place for the week of the Code Innovate. And these are the few services I would say that most of the customers, or like we get requests on, right? So Oracle Apex applications, Oracle Analytics Cloud, Digital Assistant, Integration Cloud, Visual Builder, and other use cases, right? So lot of because a lot of the use cases are also focused on AI, Gen AI services. So we do cover that services as well during the week of Code Innovate. So if you want to build something like a RAG application or want to touch base on, Oracle 26 AI vectorization of your data, right? So we can do all those different use cases as well. But yeah, that's pretty much the high level overview of what the Code Innovate program is. And if you're interested, you can drop your name in the chat. We can always touch base with you after this call, and you can always send us the email requesting on this email address.
Awesome. Thank you, Varun. Okay, so if you enjoyed today's session, we do run this as a series, so you can find any of our upcoming events at oracle.com/developer/events. And on that same page, there's also a link to our YouTube playlist, and that has all of the replays of all of our events in this series. So lots of good material there. And we'd also like to have your feedback on what you thought on today's session or on any of the topics that you'd like to see from us going forward. So we definitely would really appreciate any feedback that you have for us. And that survey, you can either grab it from this bit.ly link here, or it will also pop up as a link as you exit the Zoom today. So thank you so much for joining us here today, and we hope to see you at the next one. Thanks all.